if people just tell us. It's better if we actually work through it ourselves.
Yeah.
So, all right. So this is the problem that you posted, which is a fabulous problem. I want to talk about it, but before I get to it, I actually want to talk about what what a typical problem is, because this has three equations, it has three variables, but not every equation has all three variables.
Yeah.
So this is a little bit not standard, and it's actually, believe it or not, a little bit easier. So I want to talk about the more standard process.
Yeah.
So the more standard process is, first of all, just important that we agree and understand the only kind of equation that we actually can solve as mathematicians are equations that have one variable and one unknown. And so I call that a one by one. Like if I had a 5x equals -10,
Yeah.
everyone can solve that. Like you can solve that. It's one equation, one unknown. I can solve for that, right?
Yeah.
And then last week we worked on 2x2s, and 2x2s are bigger and they have two equations like, I don't know, 5x plus 2y equals 13 and -5x minus 8y equals 10, right? So
Yeah.
that's an example of a 2x2. So that's got two unknowns and two equations. And we do know how to solve that. We found three different methods for solving that. You can graph it, you can use substitution, or you can use elimination, right?
Yeah.
Okay, so that's what we've had in the past. Now this week we are doing 3x3s. I feel like I need to have like this really big boom box voice echoing, because these are three equations with three unknowns. I'm not even going to write one down. It's going to take too much time, but you know what that looks like. It's got an x and a
Yeah.
y and a z, and then we've got like two more equations, right? So three equations, three unknowns. Okay, but we agree that this is the only thing we can solve.
Yeah.
So the general plan of attack when we have a 3x3, three equations or three unknowns, is you're going to pick a variable to eliminate. It doesn't matter which one, but you're going to eliminate one variable. The trick here is that whatever you choose to eliminate, you're going to eliminate it twice. So we're going to eliminate z, and then we're going to eliminate z again. So you're going to get two results when you eliminate it twice. That
Yeah.
same variable, you eliminate it twice, you're going to end up with a 2x2. You're going to end up with two brand new equations that are missing that one variable that you chose to eliminate. Okay.
Yeah.
And so once you have your 2x2, you're going to pick one more variable to eliminate of the remaining variables. And once you do that, boom, you've got a 1x1. And
Yeah.
now you can solve that. Like that's what you're trying to do. So you solve it because you're super happy. And then once you have that solution, you're going to go back up the pyramid. So you're going to plug your solution into one of the 2x2s. Don't go back up to the original. Go to one of the 2x2s and solve for another variable. Okay. Once you solve again, then you're going to take both of those and you're going to plug them into the 3x3s and solve for that last variable. So you're going to solve once for one variable, once for another variable, three times for three unknowns. So that's kind of like the upside down pyramid method that I visualize when I see a 3x3. So I'm going to come back to that. Are there any questions on that before I move on?
No, the problem that I'm having is I keep getting I keep there's something wrong with the way that I'm computing it with like how I'm breaking it down. And that's what I'm getting frustrated with is because I
Okay.
keep getting left with fractions and odd numbers like that.
Okay, so sometimes the answers are fractions, and that's not wrong, but you're right. Most of our problems are rigged, thank goodness, that we get clean answers. So usually if I do get a fraction, I go back and check my work. So here's the thing about these. They're a ton of work. They should take you a full page at least. So give yourself lots of room. The other thing is that it's easy to get confused and lose a sign and get disorganized. So I'm going to show you some strategies I use to organize our work so that we don't get lost. So the first thing I do is I name my equation. So that'll be A and B and C. You can name it 1, 2, 3, however you want to name it. I use letters.
Okay.
And like I said, this one is actually easier than the typical 3 by 3 because it
Yeah.
doesn't have all the variables in all the equations, but we're going to start off the same. So the very first thing we need to do is eliminate a variable. In my head, I'm like, I have to eliminate a variable and I need to eliminate it twice, but pick a variable. It doesn't matter, X, Y, or Z. Just tell me something you want to get rid of.
We'll try to get rid of Z.
Okay, so we are going to, and I'm going to write this down, and I would recommend you write it down in your paper. Your decision was to eliminate Z. And so I need to eliminate Z, and I need to pick two equations. Again, because this problem is a little bit easier than our typical problem, I know I have to choose A and B. I can't use C because C doesn't have a Z to eliminate. So looking at equation A and B and looking at the Z terms here, I've got a -4 and a +3. I want those coefficients to be opposites of each other. They are opposite in sign, but they need to be opposite, like 4 and -4, or 3 and -3, or 80 and -80.
Yeah.
So what do you want them to be?
A has to be multiplied by 3, and then 4 has to be multiplied by 4.
Fantastic. So you want to make them 12 and -12.
Yes.
So if I take A times 3 and B times 4, right, I'm going to get those coefficients. But like you said, we're doing the entire equation, not just those terms.
Yeah.
So perfect. So let's go ahead and, oh, it's not working. Okay, great. So I'm going to take A times 3, which means I'm going to do each, wow, I'm going to do each term. So I end up with, did you get 9x? Yes?
Yep. 9x
Mine.
minus 12z
Mhm.
equals -3.
Perfect. That's exactly right. And I love that you said -3. I have when I was a student, I would often forget to do the other side. So I love that you remembered. Awesome.
Well, and I
Okay.
think that's what's happening is that I'm getting frustrated, so I'm like midway through the problem, I'm just not completely finishing it.
Right, right. And that happens. So some of this that I'm showing you, these strategies of writing everything down will kind of help with that.
Okay.
So 4 times B, you want to help me out with that? What'd you get for that?
8y plus 12z equals 8.
Equals 8. Nice job. Perfect. Okay. So now I'm going to add straight down. We're using the addition method or the elimination method. So I'm going to add straight down. Here's something that's super important. I want you to notice these two terms, 9x and 8y, they're not like terms. I cannot add them. All I can do is rewrite them. They're both positive, 9x plus 8y. That's it. The z's cancel, which is what I wanted. Yay, we wanted to eliminate that. And then everything else comes down, the equal sign, and then I have a -3 and an 8, and that gets me
5.
brilliant, +5. Fantastic. Okay, I'm going to call this equation D.
Okay.
All right. So I want to go back and talk about the plan. So the plan was to eliminate the variable twice to get a 2 by 2, right?
Yeah.
So we eliminated Z once, and in a typical system, we would go ahead and do that process again, eliminate Z again using a different pair. So instead of like equation A and B, we would use like A and C or B
Yeah.
and C, right? Okay, here's the joy and the delight of this problem. We don't have to do that
It's already
because,
done.
yeah, we already have our 2 by 2. This has two variables. This has the same two variables, right?
Yeah.
And so I've got my 2 by 2. And so now I'm ready. I don't have to eliminate twice. In this instance, I'm here at the pyramid step right here. And so I'm going to use my new system and eliminate one of those variables. We're good?
Yeah.
Okay. So I've got equation C and equation D. I need to eliminate either X or Y. Doesn't matter to me which one. You just need to tell me which one you want me to eliminate.
Let's do X.
Okay, so we're going to eliminate X, and I'm writing that down. That's my plan. And so looking just at equation C and D, I've got a 2x and a 9x. They're both positive. So what would I have to do to get those coefficients to be opposite, not only in sign, but numerical opposites?
I'm gonna have to multiply both of them to make
Mhm.
them the LCD, like the
Yes.
lowest common denominator.
Yes.
Okay.
So C times what?
Let's do -9.
-9. So this one's going to have the negative. And then D, you would multiply by
2.
+2. Perfect. So I've written that down. That's my plan. And then we'll just make sure we take -9 times every single term in equation C. So I'm getting a -18x minus
27.
20. Yes, good. Equals, what's, no, that's good. What's next?
9 times 6, 54.
And it's going to be negative.
-54.
Good.
Okay.
Okay. And then for equation D, I have to multiply that times 2. So that'll give me my positive 18x, and then
16y and
yes, it
equals
is
positive 10.
positive 10. All right. And so now I'm going to just use the addition. I'm going to add straight down. My x's are gone. Yay, that's what I wanted.
Yeah.
And then I end up with
-11
-11y.
y
Good. Equals
-44.
-44. So now I'm at my 1 by 1. And I didn't even probably need to say that because you probably looked at that and you were already like, I'm going to solve this, right?
Yeah.
Yeah, because you can. Like, you don't even think about 1 by 1s. You're like, ah, I can solve this. And so what do you get for your solution?
Y equals 4.
Y equals a +4. Fantastic.
+4.
So what that tells us is we have an ordered triple solution, right? X, Y, Z. And we know the Y value is 4. We don't know the X or the Z. And so where we're at in our process is we've just solved. So now we need to take that solution and plug it back into either one of the 2 by 2s. Doesn't matter which one, we're going to get the same result, either one you choose. So there's no wrong answer there. So do you want me to
I'm gonna do D.
D? Okay,
Yeah.
perfect. So I'm going to go ahead and copy this. So I want you to notice that the process is here that it's actually not difficult mathematics. It's just attention to detail, super important. Arithmetic is super important.
Yeah.
And if I'm going to make a mistake, it'll be in the arithmetic. So that's really frustrating to me.
Yeah.
But we're going to go ahead and take that solution that you got for y and we're going to plug it into equation D. And so I have 9x plus 8 parentheses 4 equals 5, and then solving that for x. So
This is no fair. Now it's working. Now I'm understanding this.
right? That is completely fair. What are you talking about?
Well, like I've literally been at it for 2 hours. I'm like, how is it just this simple now?
Okay. And
Okay,
so
perfect.
did you get -3 for x?
Yes. Yeah, I got
Oh, fantastic.
-3.
I'm glad we got the same thing because I told you arithmetic. We
Yeah.
-3. Okay. And so now that we have two solutions, so in our upside down pyramid, we're here. We just solved again. So we're going to take both of those and plug them into one of the 3 by 3s. However, again, because this is easy peasy,
Yeah.
yeah, you can either take your solution for x and plug it into A, or you can take your solution for y and plug it in for B. Either way, you're going to get the exact same answer for z.
And then both of the z's should equal the same in either equation, right?
Oh yeah,
Okay.
always, always. It never
Of course.
matters. So what do you want me to use, A or B?
Let's do A.
All right. I'm going to tell you right now, you're braver than I am. I would have used B because A has all of these negative signs, and I feel like, oh, if I'm going to make a sign error, I'm going to strangle myself. So I'm going to pay really close attention to my signs. I
Okay.
have a -3 in for x, and whoops, I don't have my z. Sorry, just
Yeah.
kidding. Okay, so that's all I need to do. So 3 parentheses -3 minus 4z equals -1, and then just solve for z.
Okay, so
This is one
positive.
equation, one unknown. That's kind of nice.
So it's going to be 8 -4z equals 8 equals -2.
-2, nice.
Okay.
And so that's your answer.
Okay.
-3, +4, -2. And again, if you put these solutions into any of these three equations, and to all of them, you should get a true statement. And so
Okay.
that's how you would check your answer, like on a test. Wink, wink, nudge, nudge. If you're doing this on a test and you want to make sure you got the right answer, that's what you would do. You would plug your x and z in, make sure it equals -1, y and z, make sure you get 2, and x and y. If
Okay.
you have a typical problem that has x, y's, and z's in all three equations, this process doesn't really change. It just gets longer, right?
Okay.
Um, so this just cut out an extra step, but the process is still the same.
Okay.
Right. I'm